Hello everyone. So let's go on to our next 3D geometry problem. Adam the ant is at point A of the cube A, B, C, D, E, F, G with edge length 1. He wishes to walk along the surface of the cube to point G, where G is the vertex of the cube such that AG is a space diagonal of the cube. What is the length of the shortest path Adam can take? So, to start, let's draw our cube, which all the side lengths must be the same, or all the edges must be the same. So, something like that will get us started. Alright. Now let's just move the entire thing over a little bit. So, to draw the rest of the cube, again, we want to keep the side lengths as pretty much the same as possible. So, let's do something like that. Ideally, use a ruler for this when you're at home drawing it. And like that. Okay. Then we have a dashed line. Again, let's try to keep the same length for the dashed. Dashed again is implying behind the figure. Okay. And that's good. Just connecting all the vertices now. And to finish the diagram, we have our cube, where the dashed lines represent behind the object, the solid lines are the front of the object. Now let's start labeling some of the points. So let's call, we have A, B, C, D. Now we want to walk along the surface to point G, where G is the vertex of the cube such that AG is a space diagonal. So the space diagonal is from one corner of the 3D shape to the exact opposite corner. So this point here must be G, the opposite corner through space. So imagine A is in the front top left, and G is in the bottom back right. Back bottom right. And the diagonal is going like through that cube. But honestly, that's kind of irrelevant to this problem. It's just letting us know what the locations are going to be. So A, B, C, D, E, F, G, and H. Okay. What is the shortest path that the ant Adam can walk from A to the point G along this cube? Well, if he's walking along the surface, it's kind of hard to imagine, like, to draw what's it's gonna look like. But you know how you're like, all right, you know how the Earth is round, right? But we don't perceive it like that. We perceive everything is flat, basically. That's what the journey's gonna look like for the ant. It's just a flat journey. It's not gonna really perceive that it's on a three-dimensional object, which means if it's on a flat surfaced journey, let's try to represent the situation in 2 dimensions. Now, the ant's journey begins at point A, and, well, the shortest path would be along A to the right, then going around to the other face. So starting at the face ADHE, and then moving to the face DHGC, because that's a 2-face journey instead of like a 3-faced going the other direction. Now, how can we draw that out? Well, let's just keep in mind it's a cube, so we know that the side lengths are the same. However, if the ant is walking across 2 of the surfaces, then that means if we want to represent the entire situation, that means the 2-dimensional diagram is not going to be just a square, it's going to be a rectangle. Now you might be asking why, and hopefully I'll be able to show you clearly how that works. Because we're starting this journey at point A. Then we would have, if we're looking at each surface, this would be like D, and then this would be H, and this would be E. And then it's going to walk across this surface, somewhere like this, onto the next surface, which would be DHG and C. So that is how we are going to visualize the situation. We're going to kind of unravel the prism, or the cube, I should say. So what is the shortest path between 2 points? Well, that's a diagonal, or just a straight line from one point to the other. So a straight line from A to G. So, in fact, I want to find out what this diagonal is, AG. Well, let's think about what's going on. The edge lengths of the cube are 1, which means that AD is 1, DC is 1, CG is 1, which means that AC has a combined length of 2. Well, now, since we know it's a cube, this is a 90-degree angle because the surface is a square. Now we have a simple Pythagorean theorem problem. So, AG is the hypotenuse. We would have AG squared is equal to the side length squared. So AC squared, which is 2 squared, plus CG squared, which is 1 squared. And that would be 4 plus 1, which would be equal to 5. So, if AG squared is 5, that means AG is equal to the square root of 5. And that would give us our answer. Now, another interesting thing is that when the ant is traveling from one surface to another, it kind of looks like it's crossing the one surface at the halfway point. Well, is it? Well, if we look, these 2 angles are right. These 2 angles are the same. And HG is the same as AD. So we have angle, angle, side congruence between the triangle. I'll call this point like capital M. We have angle, angle, side congruence, which means these 2 triangles are the same. So these 2 sides, MD and MH, are also the same. They would end up being half, since the side length is 1. And because of that, yeah, it does end up crossing through the midpoint of DH, traveling along that surface. Just an interesting thing to note.